Today we will work on the past school examination question together. The question is on the first part of vectors that covers the basics, the dot and the cross product. So we will run through the question, look at the question together, and briefly analyze it. I'll provide some hints on the question about which idea in the topic that may be relevant to solve the question. We will also work out the full solution together. So for the most effective learning, I highly recommend that you go through some of the key ideas in this topic before you proceed with the rest of the video. So you can do that with your own lecture notes or maybe your textbook. Alternatively, I've also produced a series of 2 lectures on this topic covering the key ideas. In the first video, we run through some of the basics, including ideas like vector magnitude, unit vectors, as well as the ratio theorem. In particular, the ratio theorem will be quite useful for this question we'll be attempting today. I'll add a link to this video. I think it should appear somewhere in your top right hand corner just about now. Alternatively, I will also post the link in the comments below. In the second video, we cover the dot and cross products as well as their applications. So for part B of this question, we will be using the dot product quite a lot. Once again, I'll provide a link to the video. It should appear somewhere in the top right or in the comments below. Also, it will be especially effective for your own learning if you were to try out the question on your own first before you look at the rest of the video. If you have managed to solve the question, well done, and maybe you want to compare your solution with mine. If not, before we work out the solution fully, before each part of the question, I will also provide a brief analysis of the question and try to link to which key idea in this topic will be most relevant to us in solving the question. Maybe that is the spark you need to solve the question. Otherwise, no worries, we'll work through the question together and hopefully learn from this particular question. So let's get to the question. So we have part A of this question. The question goes, the quadrilateral ABCD is such that P, Q, R, and S are the midpoints of AB, BC, CD, and DA respectively. Prove that PQRS is a parallelogram. So let us briefly analyze the question. In particular, we see the word midpoint. So which idea that we have learned can be relevant to help us with this question of midpoints? I think the ratio theorem will be quite useful for this part because being a midpoint means that the ratio between the two lengths will be 1:1. So if we apply ratio theorem, we can perhaps get the position vectors of P, Q, R, and S. That will be pretty useful for us down the road. Next, what does it mean to prove that something is a parallelogram? So here I've drawn a picture of a parallelogram, P, Q, R, S in anti-clockwise order. So to prove something is a parallelogram, of course we need the lengths to be parallel, in particular PQ and SR. But not just parallel, they must be the same length as well, same magnitude. So the vector PQ must be exactly the same as the vector SR. If these two are the same, the other two sides must be parallel and the same length as well. So to prove that we have a parallelogram, all we need to do is to prove that PQ is exactly the same as SR. So with that in mind, let's try to work out the full solution for this question. So as we have discussed, we will use the ratio theorem to tackle the midpoint. So P is the midpoint of AB, so using ratio theorem, we can get OP is equals to 1 times OB plus 1 times OA over 1 plus 1 giving us 2. So this gives us OP. So if we proceed in a similar fashion, we get Q is the midpoint of BC, meaning that OQ will be OB plus OC over 2. R is the midpoint of CD, so OR is equals to OC plus OD over 2. And finally, S is the midpoint of DA, so OS equals to OA plus OD over 2. So this is the first part of the question. Next, we need to prove that PQRS is a parallelogram. How do we go about doing that? As we have discussed, if we draw out the picture, we need to prove that PQ and SR are the same vectors. PQ is parallel to SR as well as the same magnitude. So let's find out what PQ is. So PQ, we will use our favorite position vector formula. PQ is equals to OQ minus OP, giving us OQ is over here, OB plus OC over 2. OP is given over here, OB plus OA over 2. So minus OB plus OA, the whole thing over 2. OB cancels out, leaving us with OC minus OA over 2. And this is as simplified as we can go for PQ. Now let's do the same for SR. SR will be equals to OR minus OS, and OR is OC plus OD, OC plus OD over 2 minus of OS, which is OA plus OD over 2. Now the OD cancels out, leaving us with OC minus OA over 2. This shows us that PQ is actually exactly the same, OC minus OA over 2. SR is also OC minus OA over 2. So PQ is equals to SR. Hence, PQRS is a parallelogram, answering the question. Now let us proceed to part B of the question. So it goes, referred to the origin O, points A, B and C have position vectors A, B and C respectively, where A is a unit vector, magnitude of B is 3, magnitude of C is √3, and the angle AOC is pi over 6 radians. Given that 3A plus C equals to KB, where K not equal to 0, considering 3A plus C dot 3A plus C, find the exact values of K. So on to the analysis of this question. So this question gives us a big clue as to where we should start our considerations. They ask us to consider 3A plus C dot 3A plus C. So how do we proceed with such a starting point? One way we can proceed is to do expansion. We can expand to get 3A dot 3A, 3A dot C plus C dot 3A, and C dot C. So we can further proceed to simplify this. We can simplify this using formulas such as A dot A equals mod A square, and we are given the magnitudes of B, magnitudes of C, and that A is a unit vector. Let's recall, what does unit vector mean? It means that the magnitude is 1. But so far, we haven't considered K yet, and the question asks us to find what K is. So the other way to proceed is to use the fact that 3A plus C is equals to KB. So we will plug in KB into this item we are asked to consider and proceed from there with the usual expansion. We are also given the angle for AOC, so when we are given angles, the dot product formula will be quite useful. We have the fact that A dot C is mod A mod C cosine of theta, and theta happens to be pi over 6 for this question. So with that, let's proceed to the solution. So we start from the question's hint. They ask us to consider 3A plus C dot 3A plus C. And we will first proceed by expansion. So we get 3A dot 3A giving us 9A dot A, 3A dot C plus 3A dot C, plus C dot 3A, which is the same as 3C dot A, and C dot C plus C dot C. Okay, we proceed to simplify. A dot A, we have the formula mod A square. A dot C is the same as C dot A. So 3A dot C plus 3C dot A gives us plus 6A dot C. And C dot C is mod C square. We are told that A is a unit vector, so mod A is 1. So 9 mod A square gives us just 9. Plus 6, we apply the dot product formula. A dot C is mod A, mod C, cosine theta, plus we're given that mod C is √3. So we have √3 squared, since mod A equals 1, as it is a unit vector. Let's proceed further. 9 plus 6 times 1 times √3 times cosine pi over 6 plus 3. 9 plus 3 gives us 12, plus 6 √3. Cosine pi over 6 is √3 over 2, which gives us 12 plus √3 times √3 is 3. 3 times 6 is 18. 18 divided by 2 is 9, leaving us with 29. So this is the first part where we just expand this and apply everything we have. However, we haven't found K yet. So how do we next proceed? We will apply the same thing we have done, but now using the fact that 3A plus C, it's KB. So the same expansion, 3A plus C dot 3A plus C is equals to KB dot KB. We can drag the constants out, getting K square B dot B, which is K square mod B square. We're also told the magnitude of B is 3, so we get K square 3 square, which is 9K square. And we've just done two ways of doing the same thing. 3A plus 3C dot 3A plus 3C simplifies to 21. At the same time, 3A plus C dot 3A plus C, it's 9K squared. Hence, we can equate the two. So we have 9k squared is equals to 21. K squared is equals to 7 over 3 if we divide the 9 over, and k is plus or minus of square root 7 over 3, and that is our answer.